Hi, Chem12. So I wanted to start by going over some answers to the balancing. There were a couple that were a little bit on the more difficult side. So let's look at 25G first. So when you're doing the oxidation number method, you only look for those that are changing in oxidation number. Okay, so like number 25G, you notice that the cadmium is 2 plus on the left and it's 2 plus on the right. So therefore it's not going through an oxidation or reduction, so you can kind of ignore that one. So let's look at sulfur. Okay, so sulfur is minus 2 on the left and 0 on the right, so that's a change in oxidation number of plus 2. The nitrogen is plus 5 on the left and plus 2 on the right, so that's a change of minus 3. So you multiply the sulfur by 3 and the nitrogen by 2. Okay, so now you get 3 cadmiums here and 3 cadmiums here, but notice that well, sorry, we got two nitrogens and 2 nitrogens. So this cadmium here, even though it's not involved, we have to multiply this one by 3 because we put the 3 in front of this one. Okay, so this was to multiply the sulfur, but that changes the cadmium to 3 of them, so we have to put a 3 there. So this is acidic, so we add 4 waters here to balance out the 6 oxygens here, so 6, and you've got 2 and 4 6, and then you've got 8 hydrogens, so we put 8 H plus on the left. Okay, and then that is balanced. Okay, N was another difficult one. Okay, so the first thing you do is you balance the nitrogens, so you put a 2 here and a 3 here, so we got 6 on both sides. Okay, and then let's look at the ones going under change of oxidation number. So manganese is plus 7 here, it's plus 2 here, so that drops by minus 5. Okay, now the one that's difficult here is the nitrogen. Okay, so if you look at what's going on with the nitrogen, hydrogen is plus 1, so that means this nitrogen is a negative 1/3. Okay, and so now we multiplied it by 2 and by 3. So what you have to do, so this went through a change of oxidation number of plus 1/3, right? So it's negative 1/3 and then it goes to 0 here. So what you do is you go 1/3, you multiply it by 2 and you multiply it by 3. Okay, and that's because of the 2 here and the 3 here. So that gets you to plus 2. Okay, so we got negative 5 and positive 2. So this one you're going to multiply by 2, and then this one you're going to multiply by 5. Okay, and so now what you get is you get, so we got 2's in front of the manganese, and then we multiply the nitrogen ones by 5. So we got 10 here and 15 here. Again, just like the previous example, the sulfate's not involved here, but we still have to multiply this by 2 because this one's been multiplied by 2. Okay, and now this is also acidic, so we look at the oxygens here. We got 8 and 8, so that's 16. Yeah, 8 and 8 is 16. So we have 8 here, so we add 8 waters, and now we have 16 hydrogens. We've got 10 hydrogens over here, so we add the other 6 over here. Okay, and that one is balanced. So remember, again, when you're balancing, you can either use the half reaction method or the oxidation number method, but it's good that you are able to know both. Okay, so today what we'll look at is redox titrations. So this is basically the same as what we looked at with, we've looked at solubility titrations, acid-base titrations. It's the same idea. Instead of titrating an acid with a base, you're titrating an oxidation or an oxidizing agent with a reducing agent. So it depends what you're working with. if you're working with an oxidizing agent as your standard, potassium permanganate is a good oxidizing agent. It oxidizes many things, and it's got two different color changes for the permanganate versus the manganese 2 plus. Okay, so purple versus colorless. So let's look at an example here. Now, the main thing here is you've got to make sure that your reaction is balanced. Okay, so a lot of the questions will give you the reaction already balanced, like this one. But if it's not balanced, then you have to use either the half reaction method or the oxidation number method to balance. Okay, so here's your standard permanganate, this concentration, and 16.7 milliliters. So we want to find the mass of the iron 2 plus. So same idea. So you take the moles of the permanganate. Okay, so that's in millimoles. Okay, and then you use the mole ratio. So this is why you need to make sure it's balanced. So there's 5 iron 2 pluses for every 1 permanganate. So we can take this number here, multiply it by 5 to get the moles of the iron 2 plus, and then to get the mass of that, let's take that from millimoles and put it into moles, and then multiply by the molar mass of iron, and then that gives you 0.050 grams. Okay. So that's if we're using an oxidizing agent. Let's look at a second example here where we're using a reducing agent. And so this one's an interesting example because here, what's different about this compared to, say, what we did with the acid-base reactions is this is going to require a two-step process. And so what happens here is your iodine ion gets oxidized to iodine gas. And then the iodine gas, the I2, is used in a subsequent reaction. So what you have to do here is you have to kind of work backwards. So let's say for this one, we want to find the copper a percentage in a salt. Okay, so what we want to do is we want to find, this is what we're looking for, okay, the copper 2 plus. Okay, and so what happens here is you have this reaction with iodine to produce the I2, and then the I2 is then used here in your titration. Okay, and so what you're using it against is the thiosulfate, okay, which is this one here. Okay, so what you do is, first thing, because thiosulfate is going to be our standard, so the first thing we do is we find the moles of that, so just multiply those two, and you get 2.45. Okay, and so this is where we start working backwards. Okay, so first thing we want to do is now use this to find out the I2, because that's common in both of these reactions. Remember, what we're looking for here is the copper 2 plus. So we there's one I2 for every 2 thiosulfates, so multiply this by a half. And so now we have the iodine. And so now that you have the iodine, use that to figure out the copper. Okay, so this is what it's basically stoichiometry involving two reactions. And so to find the copper now, you multiply that by 2 because there's 2 coppers for every 1 I2. And so this is the amount of copper we have. And then we can find the mass of copper, so change that to regular moles, divide that by 1,000, multiply by the molar mass of copper, and that gives you the mass of the copper. And then we want to find the percentage. So the percentage is going to be this mass over the mass of the entire salt, and then that gives you about 51%. Okay. Okay, so I'll stop there. So you can work on these questions here. So in terms of where we are, today is Monday. So I've got a basically, I think I'll have a new lesson for you on Wednesday, Friday, and Monday. yeah, Wednesday, Friday, and Monday. And then what I'll do is I'll give you the take-home exam next week on Wednesday. Okay, and that'll be the last thing of the course, and that'll be a take-home exam again, only on electrochemistry. Okay, and then that'll be the that'll be it as far as the course is concerned. Again, we will be able to get through everything. Keep sending me questions. Some of you have asked about your marks, so I have the marks updated. Just send me a message, and I can give you the updated percentage. It's basically the with the acid base exam. And again, just any questions or concerns you have, just make sure you send them my way. Okay. Again, stay safe, and I'll talk to you again on Wednesday. Okay. Bye now.